everybody, welcome back to the Adventures of Blink. I am of course Blink and you can find me on GitHub right here. Now today's episode is packed absolutely full of code. I may have bitten off a little more than I could chew when I was designing the way this was going to work. So before I dive into the code, I just want to make sure you remember to hit like and subscribe and hit the notification bell and all the other things you have to do to make sure you don't miss any episodes of the Adventures of Link. I'm enjoying the experience of building for you, and I hope that you're enjoying hanging out as I do. So our goal today is to build a GUI front end that's going to be the phrase editor. It's going to be the page that you go to, the screen that comes up where you can add and remove phrases from the database so that you have the ability to change what game boards are played when you start up the game. But before we do that, we actually have to go back and fix some things that we sort of left undone. If you remember back in episode 3, we were building our Flask API, which is the way that we interact with the database. And that Flask API at the time, we only built 2 routes for. We built an add and we built a random, which those are key components as far as gameplay goes. But one of the things that we're looking at in the editor is we're going to have to add some new routes in order to make it functional. So the first method we're adding to our API is getAll. And getAll is about just what it sounds like. We're going to grab every record out of the collection so that we can populate the tree view where the list of game boards is going to be. After we build the getAll, we're going to need an edit method. And edit is going to be used to change the value on an existing record. So if we misspell something or if we needed to change a word or something like that, whatever you need to do in order to make an edit to the system, this would be the method that alters an existing record. And then finally we need to add a delete because there may be a case where we go, oh, we don't actually want to have that in our database anymore. So we need to hit delete and take it out. Let's take a look at how these API methods are constructed. I'm not going to build them live, but we can see how they work here. We'll just scroll down because here is getAll. And so as you can see, it's got the same structure as the other routes that we built back in episode 3. We just tell it that its name is getAll, and it's going to be an HTTP GET request. And then we define a function, getAllItems, that fulfills that route. So it's got a try-catch sort of structure to it because we want to have error checking in our API. We want to have good error handling in the API because that helps programmers understand when they interface with us whether things are successful or unsuccessful and makes it easier for them to troubleshoot. So for the getAll, all we're going to do is define something called words, and it's just going to be a list of everything in the collection. So collection.find, you see that's sort of the generic select star. If you're used to SQL databases, then this is the Mongo version of select star from the collection. So our collection was predefined. That was part of the API that already existed. And we just said, hey, go find everything in the collection for me. And then we're going to return that as a JSON object with an HTTP 200 code alongside it. And of course, if something fails, then we're going to return a 500 code alongside the error message. Now, the next thing we're going to build is the edit. So as I said, edit is a way to alter an existing record in the collection. So its route is just /edit, and this is going to be an HTTP put. If you haven't done a whole lot of API work, that may be unfamiliar to you, but there are actually several different types of commands that HTTP supports. There's a put and a get and a post and at least one other one that's escaping me right now. But those are the things that exist in HTTP. In this case, it's a put because what we're doing is updating an existing record rather than creating something new. A post is generally used to create something brand new. Whereas a get, of course, is about just retrieving data. So edit word is our method here, and you can see the first thing we do is grab the JSON request body because it's going to have several parameters that are sent in, and we send those in as a JSON object that's attached to the request. So the three things that are being sent in are the original phrase, the new phrase, and the hint. The new phrase and the hint are the two pieces of data that we want to update in the database, and the original phrase identifies the record that we're altering. So the idea is you go find the old phrase, and then you say, now that you have that record, replace it with these 2 bits of data. So, real quick walk through this. If we don't have the original phrase, then we throw a 400 level error to let them know that they didn't give us all the data that's necessary. Then we're going to do the try catch, sort of like the one above. But then we have a collection.update1 method that we're calling here. This is how we interact with the database in the case of updating a record. And so the original phrase identifies the criteria for picking the record that we're going to update. And then we pass in a set, which is the other 2 elements that we're using to update the record in that collection. After we've done the update1 command, we have to check to see if it matched anything. So if it matched nothing, then that means we never found the record that we wanted to update. And so we should 404, just to let them know that even though that might not be a bad thing for the application, technically we didn't actually do what they asked. So it's important to be upfront and transparent about how you're interacting with the data. And then finally, if everything's successful there, we update the word, the phrase. I use word and phrase in this interchangeably, and it looks a little messy, but at some point I should go back and clean all that up. But the general idea is we send back a message that says, hey, we successfully updated your record, and we pass back a 200 to let them know it was successful in that way. Then, of course, you've got the exception. If anything happens that wasn't what we expected, then we're going to throw a 500 error, and we're going to pass back the error message so that they can troubleshoot. Now, the last route we have to add is /delete. And that was the other HTTP command that I couldn't remember. There's actually a delete that is part of the HTTP methods. So that's our setup for that route. And then we have a delete word method. Now the delete word works a little bit like the update one. It's just that you use a delete one method in the database. And in the case of the delete, we don't actually need to have all of the extra data that comes along. We're only passing in the phrase. So we're going to find this phrase and delete that record from the database. And of course, there's all the error handling to do exactly that. So that's what we had to add to our API. Once we've got these things in here, and you can see there's the add method we had before and the random method that we had as well. So there's our new API. And if you're following along and trying to build this, it's really important to remember to go back and rebuild that container from scratch. So you're going to need to do a docker compose up -- build again. To make sure that it builds the API with the new code. If you just try to rerun your container like from your Docker desktop or whatever, it's probably going to fail because it doesn't update the code. You need to make sure you're going back and rebuilding from the ground up so that you get all the new stuff in your code. All right, so with the API changes out of the way, we're ready to go back into our front end. And so today we're going to build the game editor page. This is just a window within the application that gives us the ability to update the game editor. And I'll throw a little thing up here on the screen here so you can see what our design is for this and kind of show you the finished product, and then we'll talk about how we build it. So as you can see, it's actually a list box sort of design. It's called a tree view in the framework that we're using. And so this tree view is going to be full of data, and you can do multiple columns of data within it. So you'll actually see that that's what we do. We have the first column is the phrase, and the second column is the hint, and the third column is the last update timestamp, so that we can kind of see how things have shaken out within the data. But that element is going to be populated with the getAll API call. And then there are going to be 3 buttons beneath that object, one for adding, one for editing, and one for deleting. So a brief aside here, I had to do some research on what kind of framework I wanted to use. In Python, there are several different ways to build graphical applications. I am personally most familiar with Pygame, which I used recently to build a sort of Legend of Zelda style 2D adventure. And as I was playing with it, like it was really powerful for that kind of work. But that's about animating sprites, and it's the constant moving of the screen and moving characters around on the screen and stuff like that. In the case of something like this, where we're going to be more sort of static, even if it's got graphics, it's not highly animated stuff. It's more of just we want to make sure there are images and it's clean and easy to understand, and there's an interface for people to click buttons and such. So I elected to go with a different framework in this case, one that I've never used before, and it's been an adventure to try out. It's called Tkinter. I'm not sure if you pronounce that or if you're supposed to spell things out or how that works, but I'll make sure the name gets put up here as well so that you can see. Tkinter, I've found to be very similar to working in sort of Java Swing or maybe even flavors like old flavors of Visual Basic. It's really powerful in terms of just being able to have these widgets that are ready to go. And so you say, I want to use this kind of widget, and you drop it on the screen. And then there's sort of a grid that you have to put it in. And so you tell it where it should be positioned in the grid, and you size things, and then you start interacting with the object and populate it with data or whatever. It turned out to be fairly easy to work with, and I've really enjoyed the experience. So that's what we're going to try out here. All right, so here we have the game editor file. GameEditor.py was just the name that I gave to this particular screen. You can call it whatever you want, but the name, I try to keep names very simple so that it makes sense. Like, this is the name of it, this is what it does. It's the game editor. So we've got the imports there. You see Tkinter requires us to have a few things brought in order to be able to use the widgets and be able to do stuff with it. And then the next thing you see is on line 6, I've created a constant here for the API URL. So this is how we're going to be interacting with our database. It's always going to start from this root, and then I add on the route qualifier so that it knows what it needs there. I did it in this way because if I ever decide to change the port number or how I'm interfacing with that API, I just have to change this, but I'm expecting the routes to always be the same because I'm not expecting to actually change the code of the API, so to speak, just the presentation of it in some way, potentially. But that makes it easy to be able to swap that out. If we decided we were going to run it on port 6001, for instance, it's a single change here that then propagates throughout the entire game editor. So the word editor app class is the screen, and Tkinter divides up all of the different screen elements that you want to do into their own class. So for the game editor, this is the game editor's class, and you see the constructor there. So we're calling the base constructor because this is a derived class, and so we want to make sure that it gets a chance to run that super constructor and set itself up properly, and then we add on the things that are important to us. So we're customizing the title, we're customizing the shape and size of the screen, and then we create a tree view widget. So we're calling this word tree, and it uses the ttk.treeview class. And you see it's made up of 3 different columns, and we have a note there to show headings. Now, the important thing about this setup for the word tree is in this grid, you see the column span equals 3. Column span is really important because of the way that we divide up the screen as we're working with it in code. So when you have these columns on the screen, they're sort of these logical divisions that allow you to separate out pieces of the screen to make it easy to work with. And in this case, we wanted to have the tree view to span across three different columns because we have three buttons that are going to be right below it. And so in order to put three buttons equally spaced right below the tree view, if you span the tree view across three columns, then you have three easy columns on the grid to say put a button in this one, put a button in this one, and put a button in this one. And that's how you get that shape to work out really nicely on the screen without having to do a bunch of math to figure out exactly what pixel the button needs to be on. You can sort of let the grid guide you as far as where to put items and get your spatial stuff correct. Now we have to define the column headers, and so you can see the three things there. The heading in the lowercase is the variable name that we're going to be using, and the capitalized version is what we want it to show on the screen so that it looks nice. We also set the column widths. And so in this case, they're all the same because we're sort of going with that idea that this is three columns wide. And so 250, 250, 250 makes 750 across and just equally spaced columns that appear on the screen. Then we're going to add the buttons. Note the grid items on these buttons that are all on row 1, and then you have columns 0, 1, and 2. So 0, 1, and 2 are the three columns that our tree view is spanning in row 0. And now row 1, right below that, is where we're going to have these buttons equally spaced. So this last parameter here, command, is really intriguing, and it's fun to see the way Python does this because a button requires a hook so that you know what code to execute when the button gets clicked. And you'll see here, we're actually putting method names as the parameter that's being passed in. And so the cool part about this is when you tell it command equals self.addWord popup, that's saying in my class here for this screen, I'm going to have an addWord popup method that's going to be called whenever this particular button, the add button, is pressed. And so each of those gives you that ability to set that command that way, and it will execute the code in this method just based on the idea that you click the button. Now, the last thing that we do in the constructor is load the words. So the load words is the call out to the database to do that get all method and pull back all that data and fill the tree view with it. So here's how this works. It's a simple try catch on this side. We are big fans of trying and catching. It's really important to make sure that your error handling matches up well. You don't want to have big nasty messages that break your application and crash everything. So handling failure gracefully is one of the best things you can do as a programmer. Now, for every item in the word tree get children, we're going to delete. All I'm doing there is clearing it out before I add new things to it. That way, every time I load the words into the page, because this is going to happen on refreshes and stuff like that, every time I do that, I want to make sure I'm clearing out what was in there before and pulling in everything fresh. Now, here is the HTTP call over to our API. And we talked a little bit about this in previous episodes about how easy it is to deal with your data, but take a look at that. It's just, hey, go get this. Here's the URL you go to, and we're going to add the get all as the route that we're calling. And if we get back a 200, then we know that the JSON object that came back in the response is what we need it to be. Otherwise, we're going to throw an error and say, hey, something went wrong. But once we have that data, we can insert it into our word tree. And so that's how you build the object, and it's going to start populating all the rows so that you can see all the different potential game boards. Now, once we get past the load words method, let's look at some of the other things that exist. We have an add word popup. So what are we doing here? Well, as it turns out, when you click the add word popup, this is the method that's called when you click the button. And all it's going to do is call a separate method the edit pop-up and build out the edit with a callback to add the word. Now that's a whole mouthful, but let's talk through what's going on here. So this is the method that fires whenever you click the button. Its job is to call the edit pop-up, which is a thing that you can build down below. We'll look at that in just a moment. You can actually see the call for the signatures right there. But the idea is the pop-up screen always has the same elements whether you're adding or editing. So we can reuse that and not have to duplicate code. And that's really powerful because now I have one thing that I can populate in two different ways, and it makes my code cleaner to work with. Now, it might be a little more confusing. You could argue that, but I think once you get the hang of reading this, you'll be able to follow it really well. Now, part of that edit pop-up is that it needs to know where to call back to in order to do something when somebody clicks the save button. So the edit pop-up call here has a special callback. And the idea is that it's a simple window with two fields on it. There's one for the phrase and one for the hint. And so you're going to fill in those fields, and then there's a save button on the form that says, I'm ready to save this update, or I'm ready to save this addition. And this callback tells the save button what it should do in each case. So when it's called from the add word pop-up, it uses self.addWord. When it's called from the edit word pop-up, you'll see the save callback right here uses the edit word method. So they can behave in slightly different ways. Now, why does that happen? Because on the add word, it's going to be blank to start with. On the edit word, it's going to be pre-populated because it's an existing field. Now, in addition to that, the saves behave differently too, because in the add case, it's just, hey, I'm throwing this at the database. In the edit, I have to know where that record was because it's being altered. So in order to handle that, the save callback can be overloaded, or not necessarily overloaded, but it's used in different ways depending on its context. So really powerful features of the language that give you some flexibility in the way you define things. And that flexibility means you can reuse a lot more code instead of having to build out these entire trees separately. So your add word pop-up is there, your edit word pop-up is here, and the edit word you can see actually does check the selection and pull in the values that it's going to use. And then when it calls the edit pop-up, this is how we actually put the screen, like the pop-up thing on the screen with the two fields and the save button. And so it's always going to have the title, and then it's going to have the optional word and hint and callback. And so how we send those data points in determines the behavior that we get. So if a word is provided, then it's going to pre-fill it. And so this is how you do, like on the editor screen, you say, hey, you clicked on item 5 in the list, and item 5 had the word pickle juice, right? And so it will pre-populate the editor with that so that you have the existing word that you can then change, or you could even wipe out completely. But it gives you that ability to populate it ahead of time. If it doesn't have that, it just skips it and leaves it blank, which is the case for like an ad, because the brand new ad should be blank. It's not going to prompt you with any current data. Now, once we've gotten through the idea of building this edit pop-up, and you can see here, it's just a matter of making a label and then following it with an entry box, and then setting the grid elements so that it's all lined up the way we want. And then you validate whether you're going to put any data in there to start. And then your save button is right down here, which is just, we're going to do the save callback, and we're going to pass back in the new phrase. In this case, it says word, the new hint, and then the type of pop-up that it was. And then there's where you put your save button. So now we've populated this whole save button, and we've given it the information that was passed in as far as how we're going to behave when somebody clicks it. Finally, uh, we have the methods that actually do the work afterward. So add word is what happens when that save button is clicked from an add perspective. So if you're adding a new thing, like if you did the add button on the main page and got the add pop up, then this would be the one that fires when you click save there. So it's calling the add route, and it knows it needs to pass in the phrase and the hint, which have been provided to it. And it does the check to make sure it's been successful. If it has, then it reloads the words and destroys the pop-up. Otherwise, it's going to send a message that says, hey, I tried to add this and I couldn't do it. And then, of course, you have the master exception, if you will, that says, hey, I had a terrible error and I'm not sure what went down. But just to let you know, everything broke. So next we have the edit word. In this case, we look at the selection, and if they haven't selected a word, then we can't proceed, because part of getting here is knowing that I clicked on an individual item in the array. And so, oh, look, that's the one that I'm editing. If you haven't selected that, I don't know what you're trying to edit. So the edit button should just not do anything. Now, assuming that you have selected something, you can see the try catch here, and it works in very much the same way. You just replace add with edit in your URL. So there's the route that goes. And of course, we talked about this earlier, that you have to pass the original phrase, the new phrase, and the hint in the case of doing an edit, so that it knows what record it was going to fix and what it's going to change it to. All right, so finally we have delete. Delete word works just like the ones above, except that it's going to only pass in the original phrase, and of course it uses the delete route. So it passes in this data, and the API takes care of it. If the API successfully deletes the record, then we get back a 200, and we know to reload our page and show current conditions. And then of course you have the app initialization stuff at the bottom of this. Okay, so now that we've been through all of the code in our class, we're ready to try this out. So I'm going to come down here and I'm going to run Python gameeditor.py. Because this thing is a self-contained class, it actually has the ability to start up without the rest of the app even being written yet. And we can just focus on getting the game editor to work the way we want. So I'm going to run it like that, and you'll see it pops right up here like this. You see our phrase editor. We've got our tree view up here that shows the 3 columns that we're interested in, and we're ready to try to do some stuff. So let's come here and let's do roads go ever on. Good Tolkien sort of thing. And in fact, I'm going to do that. We'll just put Tolkien as the hint. And then I can click save, and you see it adds it to the list. Now, maybe I need to be clearer about this, and I need to say, you know what, that actual quote from his poem was, "The road goes ever on and on." And so I'm going to update it, and there we go. It's now changed that in the database. And then maybe I'd say, you know what, that's not really part of the theme that I'm going for. Let's just delete that one altogether. And so a quick delete, and it's out. So now we have the ability to manipulate our database from the front end. Just like that, we've connected from a graphical front end through the Flask API and all the way out to our Mongo database. So there you have it. We've built this thing end to end. We have a graphical screen that runs on the front end, and you can interact with it by clicking buttons and typing things, and that passes things to an API that populates a database. It's really fun for me to see all the pieces come together and start to work in concert. It's always fun to see them in isolation, and you can sort of get a taste for it along the way using some of the test automation tools and things that we've looked at. But nothing really beats the idea that I said, hey, I'm starting this up and it runs all the stack together. So I hope you're having as much fun with this as I am, and I can't wait to see what you've built with it. Drop me a comment in the chat down there. I'd love to hear a little bit about what you're doing with it. Maybe as you're building, you've edited in different ways and you've come up with other ideas that you want to share. I would love to get a look at your code and we can share ideas back and forth. At any rate, I can't wait to see what you build, and I hope you're having a blast. We'll see you next time.